Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to YouTube channel Chandan Physics. In this video, we are going to discuss a little bit idea on lattice vibrations and phonons. Let's begin. Lattice vibrations. Two words. One is lattice, another one is vibrations. Lattice, the array of points in space having equal surroundings. Let me consider in two dimensions the array of points in space having equal surroundings. In that of lattice point, we replace by a group of atoms which is known as the basis. With the combination of lattice plus basis, we obtain the crystal structure. In that of lattice point, a group of atoms are arranged. So, what is lattice vibrations? Every atom has a tendency to vibrate about their mean position. What is the condition? At temperature above 0 Kelvin, means there will be some kind of temperature. The temperature is above 0 Kelvin, then every atom can vibrate about their mean position. The mean position is referred as the Bravis lattice height. Let we take that point at the mean positions, and these mean positions we refer as the Bravis lattice height. And these vibrations occur due to interatomic interactions. Why these atoms are vibrate above 0 Kelvin temperature? Due to the interatomic interactions in between these atoms. As the atoms in the solid are present in that of lattice sites, so we call that kind of vibrations is called lattice vibrations. The vibrations of these atoms, and these atoms are present inside that of solid, is known as the vibration referred as the lattice vibrations. Why we know about the lattice vibrations? What is the physical importance to study about lattice vibrations? When we are dealing with crystal structures or solids, a basic property, that is the thermal properties of a solid, can easily understood by the help of lattice vibrations concept. Therefore, it is too important to us to study about lattice vibrations, that indicates a detailed study of thermal properties of solids. In lattice vibrations results the absorption of heat energy. The lattice vibrations are the result of the absorption of heat energy. Heat is absorbed during that of lattice vibrations. A lattice that is an array of atoms that connected with each other by elastic springs. Or strings. These atoms are connected with elastic springs. These are the elastic strings or strings through which all the atoms are interconnected with each other. Actually, these atoms are interconnected with each other by the atomic bonds. As we discussed about lattice vibrations, we assume there will be the springs through which each atoms are interconnected with each other. Due to that, here all the atoms present at lattice sites are coupled. These atoms are interconnected with the elastic springs. Therefore, that atom present on that of lattice sides are treated as a coupled, and its motion, the motion of one single atom is shared by the neighboring atoms. That atom is interconnected with that string, this string again that atom is interconnected with, here is a string, there will be a string. All the atoms present at the top lattice sides are referred as the coupled, and the motion of one single atom is shared by the neighboring atoms. As a result, the crystal vibration on a whole, totally the crystal is vibrated. Means above 0 Kelvin temperature, that atom is vibrated. Due to that atom is interconnected with the elastic springs, and one single atom shared by the neighboring atoms. Due to the vibration of that of single atoms results the vibration of the entire crystals. Again, a property, the dynamic external forces which are responsible for the vibrations obey Hooke's law. As there will be the presence of elastic springs or strings, so if we apply an external force into that of crystal structure, that also results the vibration of the crystals, and that kind of external force obey the Hooke's law. Hooke's law in elasticity holds good in the case of lattice vibrations. Next point, it is assumed that the amplitudes of the vibrations are small as compared to the interatomic spacing. The distance in between these atoms is high when we are compared to the amplitudes of the vibrations. And the harmonic approximation is valid for lattice vibrations. Harmonic approximation is also valid for that. Due to that, every atom present at lattice site is considered to be an harmonic oscillator. Harmonic oscillator. Each of these atoms act as an harmonic oscillator. These are some basic properties related to lattice vibrations. Basic properties. Next, discussing about phonons. Phonons the concept of phonons first of all introduced in 1932 by Soviet physicist Tam, and he was also awarded the Nobel Prize in Physics in the year of 1958. Phonons, the name phonons, that derived from a Greek word as the combination of phone, the word phone, which means sound or voice. And this is because the long wavelength phonons give rise to a sound. Let me show what is phonons. When we are discussing about an electromagnetic wave or electromagnetic energy, the electromagnetic energy is quantized in nature, and that quantization of electromagnetic energy is known as photon. The energy in a lattice vibration or an elastic wave is quantized, and this quantization of lattice vibration energy is very similar to the quantization of electromagnetic energy. In case of electromagnetic energy, the quantization is known as photon. Same thing in case of lattice vibration energy, that quantization of lattice vibration energy is known as phonon. The quantization of electromagnetic energy is known as photon, whereas the quantization of lattice vibration energy is known as phonon. A photon, that is the quantization of electromagnetic energy. A photon travels with the velocity of light, whereas the phonon with the velocity of sound in solid. Photon travels with the velocity of light, phonon with the velocity of sound in solid. photons do not require any kind of material medium for its propagation. For their propagation, whereas phonons phonons do need a material medium to travel. Thus, phonons can never travel through a vacuum. An electromagnetic wave propagates through the vacuum, but phonons need the material medium for its travel. Therefore, they can never travel through a vacuum. As we say, electromagnetic energy is quantized, and that quantization is known as photons. In that of case, lattice vibration energy is quantized, and that quantization is known as phonons. So, what will be the energy? So, mathematically, the energy of lattice vibrations or that is known as the phonon, the energy of phonon is given by the energy is equal to h cross omega, where h cut is equal to h by 2 pi, as h is the Planck's constant, omega the angular frequency of vibration, Let me take a situation when a space lattice is excited in its nth state. There will be n number of phonons, and each phonon has an equal energy which is equal to h cross omega. Then n phonons, each of energy h cross omega are present. For excitation, if one phonon is released, one phonon is released when the lattice transits from nth mode to n minus 1th mode. There will be a transition. The lattice transits from nth mode to n plus 1th mode. Similarly, during the transition from n minus 1th mode during the transition from nth mode to n minus 1th mode, transition from nth mode to n minus 1th mode, a phonon is said to be destroyed. A phonon is said to be destroyed. Okay. If a transition occurred from nth mode to n plus 1th mode, one phonon is released. One phonon is released. At the same thing, when it transits from nth mode to n minus 1th mode, then a phonon is destroyed. Here a phonon is released, here a phonon is destroyed. In this way, we say phonons, an important point, phonons are created and destroyed during the transition of lattice from one mode of vibration to other. So, phonons are created and destroyed during the transition of lattice from one mode of vibration to other. In that of point, we just analyzed, if it is transit from nth to n plus 1, one phonon is released, but when it is transit from n to n minus 1th mode, one phonon is destroyed. This is the idea of phonons, that is the quantization of lattice vibration energy, and that travels with the velocity of sound in solids, and it can never travel through vacuum, as it required a material medium for its propagation, and its energy is equal to h cut omega, and it is created and destroyed during the transition of lattice from one mode of vibration to another. Here, with the help of this video lecture, we understand the concept of lattice vibrations. What is lattice vibrations and some properties related to lattice vibrations. Basic idea about phonons. So, with this useful and informative notes, let me wind up this session. Thank you.